If you've ever cranked up your system and the music suddenly turns harsh and distorted, you've heard clipping. It's not your broken gear. It's a gain and sensitivity mismatch between your DAC and preamp and possibly power amplifier. In this video, I'll break down the key electrical concepts you need to know to match your source, be it your CD player or your streamer or your DAC, to your preamp and amplifier or integrated amplifier. Understand the whole system's gain structure and get the clean, dynamic sound your system is capable of. I made a detailed video on matching preamp and power amps last week. I'll post a link in the description. And some of you reached out by email asking for help with source to preamp or integrated amp matching. Not quite the same as preamp to power amp matching, but the concept can be easily explained in thus this video. So before we jump to the fix, we need to understand the problem. What is that awful clipping distortion sound really? When audiophiles talk about distortion or clipping, we're not just throwing around fancy words. We're describing something specific, audible, and measurable. This isn't the nice warm saturation you might get from a tube amp being pushed a little bit. No, this is way more destructive. It often shows up as a harshness in the treble, cymbals which should have a clean metallic shimmer and a long natural decay will sound more like a spray of shattered glass. A female vocalist's high notes, which ought to be clear and soaring, become sharp and painful to listen to. There is a little brittleness to everything, a sense of sonic fragility where you expect strength and body. Another dead giveaway is a total loss of dynamics. A well-recorded track has peaks and valleys. The quiet parts pull you in and the loud crescendos hit you with real impact. When your system is clipping, those peaks get locked off. The difference between the quietest and loudest sounds shrink. The music sounds compressed, lifeless, and squashed. The impact of a kick drum turns from a chest thump into a dull thud. You might also hear what sounds like a smearing of the instruments. In a system that's working right, you can, without even closing your eyes, place every musician on the soundstage. The piano's over there, the bass is in the middle, the singer's right in front of you. When clipping happens, those images blur. The separation between instruments dissolves into a congested, confused wall of noise. That's because the distortion is adding new, unwanted frequencies that never were in the recording, and these harmonics just muddy the waters. The real frustration is knowing you have great gear. You read the glowing reviews, you've invested in quality, and the result sounds cheap. It feels like your components are fighting each other, strangling the music instead of letting it breathe. This is the core of the problem, the maddening gap between what your system could be doing and the disappointing sound coming out of your speakers. The most important thing to get is that this is an electrical problem, a traffic jam in your signal path, and like any traffic jam, you can clear it if you understand the flow of traffic. To solve this puzzle, we need to know the pieces, the relationship between your DAC, your source, your preamp, and your power amp or integrated amp. Comes down to a few key electrical specs. They might sound technical, but the ideas behind them are surprisingly simple. Once you get these, everything else clicks into place. Let's start with the source's output voltage. Think of your audio signal as water flowing through a hose. The DAC converts the digital ones and zeros into the stream of analog music. The output voltage, measured in volts RMS, is the pressure of that water. It's the electrical force pushing the signal out of the DAC and down the cables to your preamp. A DAC with a higher output voltage is like a faucet cranked wide open. You'll find this number in your DACS manual. There is no single standard, but there are some common values. For unbalanced outputs using RCA connectors, a typical max output is around 2 volts. For balanced outputs using those 3-pin XLR connectors, the standard is often double that, around 4 volts or even more. This difference is a huge deal, and we'll come back to why it's such a common trap. For now, just remember, DAC output voltage is the push. Next up is your preamplifier's input sensitivity. This is arguably the most misunderstood spec in all of hi-fi. The name is tricky. It has nothing to do with how sensitive or detailed the preamp sounds. Instead, a preamp's input sensitivity tells you the maximum input voltage it can handle cleanly before it overloads and starts to clip. Let's go back to our water analogy. If the DACS output is the hose, the preamp's input is the bucket you're filling. The input sensitivity spec tells you the size of that bucket. A preamp with an input sensitivity of 2 volts has a 2 volt bucket. A preamp with an input sensitivity of 1 volt has a smaller 1 volt bucket. If you try to force 4 volts of signal from your DAC into your preamp with a 1 volt bucket, it's going to overflow. That overflow, that spillage, that's clipping, that's distortion. So a more sensitive input, one with a lower voltage number like 1 volt, is actually less tolerant of a high voltage signal. It's a smaller bucket, easier to overload. A less sensitive input with a higher number like 4 volts is a bigger bucket that can handle a much stronger signal flow without breaking a sweat. Finally, let's talk about gain. If the preamp's first job is to catch the signal from the DAC without spilling, its second job is to amplify it, to make it bigger and stronger so that it can properly drive your power amplifier. That amplification is called gain. Gain is basically a multiplier. It takes the voltage it got from the DAC and multiplies it by a certain amount. Gain is usually expressed in decibels or dB. The math can look scary, but the concept isn't. It's just a convenient scale. We're talking about big multiplication factors. The most important rule of thumb to remember is this. For voltage, an increase of 6 dB means you've doubled the signal's voltage. An increase of 20 dB means you've multiplied it by 10. When you turn the volume knob on your preamp, you are controlling its gain. At its lowest setting, the preamp might have no gain, unity gain, or even negative gain, which just means it's turning the signal down. As you turn it up, you apply more and more gain, multiplying the input signal. So think of gain as the preamp's main tool for resizing the signal to be just right for the next component in the chain, your power amplifier. Okay, so to recap, DAC output voltage is the signal pressure from your source. Preamp input sensitivity is the maximum pressure the preamp can take. Gain is the multiplier the preamp applies to the signal. The problem starts when the pressure from the hose is way too much for the size of the bucket. Okay, now that we know the terms, let's connect the dots. Let's look at exactly why a mismatch creates such an awful sound. This is where the spec sheet meets reality. Let's start with the most common and destructive problem, the overload. Imagine you have a high-performance DAC, maybe one that's popular in recording studios. It's a beast, and its spec sheet says it has a balanced output of 4 volts. You're excited, so you connect it with XLR cables to your high-end preamp, but your preamp, while fantastic, was designed mostly for consumer gear. Its manual says its maximum input sensitivity is 2 volts. See the problem? The hose is pushing out water with a pressure of 4, but the bucket can only hold 2. The very first time the DAC sends a full strength signal, it's sending double the voltage the preamp's input was ever designed to handle. The preamp is being totally overloaded. It has no idea what to do with this massive extra signal, so it just chops it off. It clips. Think of a pure musical note as a smooth, rounded sine wave. When the preamp gets overloaded, its electronics are pushed past their limits. They physically cannot reproduce the top and bottom of that wave, so they just flatten them. That beautiful rounded wave gets turned into a crude square wave. This squaring off is what creates distortion. It creates a whole flood of new frequency harmonics that were never in the original music. These are what we call odd-ordered harmonics, which the human ear finds especially grating and unpleasant. This is the harsh, brittle sound you hear. It's the sonic equivalent of adding jagged edges to a smooth ball. It happens every single time the music hits a peak. The louder the track, the more it clips, and the worse it sounds. This brings us to gain staging and headroom. Gain staging is just the process of setting the level for each component in your audio chain to get the best performance without distortion. Every box that can amplify or turn down a signal, your DAC, your preamp, your power amp, is a gain stage. Related to this is headroom. Headroom is your safety margin. It's the space between the average level of your music and the absolute maximum level your gear can handle before it flips. Think of it as the empty space at the top of a glass of water. You don't fill it to the very brim because the second you move, it will spill. You leave some headroom. In our overload scenario, the 4-volt DAC feeding the 2-volt preamp, you have a negative headroom. You are starting out already past the clipping point. The battle is lost before it even starts. The ideal setup is to have your gain structured so the average signal has plenty of room to breathe, far away from the electronic noise floor, but also far from the clipping point. If your signal from the DAC is already too hot, it forces you to keep your preamp volume turned way down. This might stop the clipping, but it's bad gain staging. You're using your expensive preamp not as a preamplifier, but as a bandage to fix a problem that shouldn't be there. And let's not forget the final stop, the power amplifier. The whole point of the preamp is to prep the signal for the power amp. The power amp also has an input sensitivity rating. That number tells you how many volts it needs from the preamp to deliver its full rated power to your speakers. For example, a big 200-watt amp might need a 2-volt from the preamp to hit that full 200 watts. So the real goal is to set the preamp's gain so that at the loudest listening level, it's sending the right voltage to your power amp. See link card above for a detailed preamp to power amp matching video. Let's walk through a healthy example. Your power amp needs 2 volts for full power. Your DACS peaks are at 1 volt. This is well within your preamp's limits. To get the 1 volt signal from your DAC up to the 2 volt the power amp wants, what do you need? You need to double the voltage. And what did we say doubles the voltage? A gain of plus 6 dB. In this ideal world, you'd set your preamp's gain to 6 dB. Now, the DAC and the preamp are both operating comfortably with plenty of headroom, and the power amp is getting the exact signal it needs to perform its best. The whole system is working in harmony. One last critical complication: balanced versus unbalanced cables. As we mentioned, balanced XLR cables typically carry double the voltage of unbalanced RCA cables, plus 6 dB. This is a very common source of problems. People hear balanced is better, so they switch from RCA to XLR cables without realizing the consequences. If your system was perfectly matched using RCA, switching to XLR can instantly throw it into overload. It's not that balanced is bad. It's fantastic for rejecting noise, but you have to account for its higher voltage when setting up your gain structure. Here's another link above for a detailed balanced versus unbalanced systems video. All right, enough theory. Let's get to the practical step-by-step guide to analyzing your system and dialing it in perfectly. Grab your manuals or get ready to do some Googling. First things first, we need to gather some intel on your equipment. you're looking for 3 key numbers. You can usually find these in the user manual or printed on the back of the gear itself or on the specs page of the manufacturer's website. The 3 numbers are your DACS maximum output voltage. This will be in volts or VRMS. Look for separate ratings for the unbalanced RCA and balanced XLR outputs. For example, it might say RCA 2.2 volts RMS, XLR 4.4 volts RMS. Number 2, your preamplifier's maximum input voltage or input sensitivity in volts. This is the bucket size. It might be labeled max input voltage, input overload level, or input sensitivity. Again, it will be in volts or VRMS. Number 3, your power amplifier's input sensitivity. This is the voltage the power amp needs to hit its full rated power. It might be labeled input sensitivity for rated output. A common value is something like 1.5 volts RMS. We'll find these numbers, write them down. This is the foundation for everything else. Now, look at the first 2 numbers, your DACS output voltage and your preamp's maximum input voltage. The big question is your DACS output voltage higher than your preamp's maximum input voltage? If the answer is yes, example, your DAC outputs 4 volts and your preamp clips at 2.5, then congratulations, you found the main source of your distortion. You have a fundamental mismatch that you must fix. If the answer is no, your DAC outputs 2 volts and your preamp can handle 4 to 5 volts, then you're safe from input clipping. That's great news. If you still have a problem, it's probably somewhere else in the gain chain, but your basic connection in the source is solid. Now, if you've just discovered your DAC is yelling at your preamp, you need to turn down or attenuate that signal before it gets to the preamp. You have a few ways to do this. Option A, the DACS volume control. This is the easiest fix. Many modern DACs have a digital volume control or a switch for the output level. If your DAC has this, just turn down its output. The goal is to get its maximum output safely below your preamp's max input level. Some DACs even have jumpers or menu settings to switch between a high output pro mode and a lower output consumer mode. This can solve the problem in one click. Now, some will argue that volume control on the DAC will truncate resolution. That's a subject of discussion for another video. Now, option B, use inline attenuators. What if your DAC has a fixed high voltage output and no volume control? No problem. You can buy external inline attenuators. These are little passive plugs that go between your DAC's output and your cable. They're just resistors that reduce the signal voltage by a fixed amount, usually in dB, like minus 10 dB or minus 14 dB. Companies like Rothwell make high-quality ones that are sonically transparent. A minus 10 dB attenuator will cut the voltage by about a third, which is often enough to solve a mismatch. Option C, the preamp's gain switch. Some preamps have gain switch with settings like 0 dB plus 6 dB. If your input signal is too hot, your first move would be to pick the lowest gain setting, which is often 0 dB or unity gain. This means the preamp isn't adding any amplification, giving you the best chance of cleanly handling that hot signal. Now, if both your DAC and your preamp have no gain trim, then you really have one lever, the volume control on your preamp. Now, step number 4, setting the preamp gain for the power amp. Once you've made sure that the signal coming from your preamp is safe, the next job is to set the preamp's gain so it drives your power amp correctly. Remember that third number we found, the power amp's input sensitivity, that's our target. Now let's walk through a real-world example. Power amp spec needs 1.4 volts for full power. This is our target. DAC spec max output is 2 volts RMS. Preamp spec max input is 5 volts RMS. It has a gain setting of 0, 6 dB, or 12 dB. First, the sanity check. The DAC at 2 volts is less than the preamp input of 5 volts. We're safe from clipping here. Now we want the preamp to output 1.5 volts to the power amp, but our DAC is already sending 2 volts. We actually need to reduce the signal. In this case, the best choice is the 0 dB gain setting on the preamp. At this setting, the preamp acts mostly as a passive volume control. When you turn the volume all the way up, it will output roughly 2 volts it received. This is a bit more than the 1.5 volts the power amp needs for full power, which just means you'll hit your preamp's limit before your volume knob hits its max. This is perfectly fine and very common. Now, for a different scenario, let's say your DAC only outputs 0.75 volts. Power amp target is 1.5 volts, DAC output is 0.75 volts. Preamp gain options are 0, 6, and 12 dB. Here we need to turn 0.7 volts into 1.5 volts. We need double the voltage. And what did we learn doubles the voltage? A gain of 6 dB. So in this case, you would flip the switch on your preamp to the plus dB setting. Now your system is staged perfectly. The preamp is adding just the right amount of amplification for the power amp to reach its potential. Choosing 6 dB would leave you underpowered, and 12 dB would give you way too much gain, making the volume knob hypersensitive. Again, if your preamp has no gain switches, that's okay. Simply run the preamp knob at a lower rotation. It's not wrong to listen at 9 o'clock instead of 2 o'clock. What matters is clean, undistorted sound, not the knob's position. But you might not have the fine control of volume steps that you might like to have if your preamp gain is too high. Again, here, inline attenuators between preamp and power amp, or between DAC and preamp stage. If you're using integrateds, that lower output will be your friend. The math, the specs, the examples are here to get you in the right ballpark. They help you understand gain structure and potentially solve major electrical mismatches. But the final fine-tuning should always be done with your ears. Start with the volume knobs. Turn down. Put on a piece of music you know inside out. Something with great dynamic range. Now slowly turn up your preamp's volume. Listen carefully. Don't just listen to the music, listen to the character of the sound. As the volume goes up, does it stay clear and effortless? Or do you hit a point where it starts to sound strained, harsh, or congested? The second you hear that sound change for the worse, that's your system's clipping point. Back up a notch to where it's loud enough without distortion. That's your absolute maximum. Make a mental note of that position on that volume dial and don't go past it. A well-staged system should let you use a good portion of your volume knob's range. If your normal loud listening is barely at 9 o'clock, your system gain is almost definitely too high. If you have to crank it to 3 o'clock or 4 o'clock for normal volume, your gain is probably too low. The sweet spot is having your comfortable loud listening happen somewhere between 11 o'clock and 2 o'clock on the dial. This gives you that fine control, and it means all your components are happy. So there you have it. We've gone through from frustration of distortion to a clear methodical solution. This process is simple. First, do the detective work. Find the specs for your DAC, preamp, and power amp. Second, do the sanity check to see if your DAC is overloading your preamp. Third, if there's a mismatch, use the tools you have, the DAC's volume, an attenuator, or the preamp's gain switch to tame the signal. And finally, set your preamp's gain to match your power amp, using your ears as the ultimate judge. By doing this, you're taking control of your system's gain structure. You're turning your collection of expensive gear that are fighting for each other into a harmonious system. The benefit isn't subtle. It's the difference between harsh, fatiguing noise and clean, effortless music. You're finally unlocking the performance you paid for, ensuring your investment rewards you with beautiful sound at any volume. You now know how to diagnose and fix one of the most common and frustrating problems in audio. You are the master of your system's gain. If you have questions about your specific setup, I am planning to open up one-on-one consulting shortly. So look out for that soon. You will also find interesting video cards on your screen now to expand your knowledge by watching these easy to follow explanation videos. This can be a tricky and confusing subject, and I will do my best to help you out. Thanks for watching.